I explained some points. The problem is that the neutrino oscillates between the properties of an electron and of a positron, and the average of the charge is 0 and the mass as well. So this is what we are measuring. But the effective value is not 0. And you know, just like AC current, the average of the voltage of the current is 0, but the effective value is not 0. So it's up to what you are measuring. And the result is that you have a particle with no charge, with no mass, but it has energy and it has impulse. And this is the only possibility to explain why these particles exist. And we call them neutrino. And our solution will be that this energy is free energy. We are able to use it at any time and everywhere as an available energy resource. And this, I think, is in interest to us as we are looking for energy. So the neutrino is a physical particle. And that's why I'm working with this model of neutrinos. And I don't work with 0-point energy because 0, there's nothing. I don't work with, vacuum field energy or something. Vacuum, there's nothing. So you see, the neutrino exists. They have given the Nobel Prize to the neutrino research in 2002, and so this is existing, and you have a particle that exists and that has energy, is carrying energy. You only have to find out how to interact with this particle. Well, let's have a quick look. You know that they measured a rest of the mass, but this causes that the speed has to be slower than the speed of light. Well, but the neutrinos are coming from a black hole, and a black hole is black because there is no light coming out. So the neutrino has to be much quicker than speed of light if it wants to come out from a black hole. And this is what Tesla said. And well, I think the water in these big detectors, this water breaks the radiation, and I explained it in that way. If the water molecules are oscillating in resonance with the neutrino, they give energy to the neutrino, they are break by this, and the neutrino will become an electron or a positron. If it is a positron, an anti-matter, then you see lightning. This is what they are measuring. If they measure only some lights a day, these Cherenkov radiation, and if this is only one part they are measuring nowadays, and the other, the electron, founds neutrinolysis, that is splitting water, you see. So this is what we can use. Perhaps you know Stanley Meyer. This would be one application to split water by neutrino radiation. I have this as an example. Well, it has to do with these open field lines outside an electron. This is the model of the electron, and you have to realize this in a technical device. And so Stanley Meyer has used just the same charge. Okay. Then we had another problem. The third problem was that the quantities were different. We had only 3 billion measured in the Kamiokande, but 66 billion neutrinos measured in the Galax detector of the European detector. And the question is, why this? The colleagues of science had been very astonished that they measure only such small parts. They have not expected. And was it a fault in measurement or in the model? Well, my solution would be that by the Kamiokande, we are measuring the light. The light means we measure that part that is materializing of the neutrinos that are materializing into antimatter. That is only the smaller part. And in presence of matter, we get much more electrons, and they are splitting water. But this is not measured nowadays. This had been measured by the Galax detector, and so we have this relation that is as well the relation we are measuring at the sun. If you calculate what the sun is producing light, or the sun is producing matter and is growing. So we have the same effects. Well, the question is, science are discussing whether the first hypothesis, are the neutrinos changing but not measurable, or are they absorbed? If they are absorbed in the center of the Earth, then the sun supplies the Earth with neutrino power. This is the consequence. And this is very easily to understand. But on the other hand, this one is not easy to understand, but this is honored by a Nobel Prize. Well, this is the back of the medal. You see. In both cases, we have the problem that the interaction with the center of the Earth, with the core, is much bigger than the theory allows it to be. Much bigger, 10,000 times bigger. So we have a problem with the interaction because the weak interaction, it cannot be. And this is what I describe here on this slide, that if we have only the static interaction, we have gravitation, or we have electromagnetic interaction. If it is oscillating, then the average is zero, though we speak about levitation. And if the electromagnetic interaction is as well changing in time, then I speak about the resonant interaction. And the weak interaction is only a special case of this. And this resonant interaction, this is working if neutrinos are interacting with the core with the center of the Earth. I think now I have to stop it, or I get enemies. Thank you very much.